Hello everyone, and welcome back to my Messy Lab. Today I have another interesting project which I'd like to share with you. This is an external floppy drive which I wish to have since a while. So I will go to remove all the packaging and see how it is. Okay, now I should be able to remove all these bubbles things here, and look at that. This is of course an IBM. The model is 4869 and it is a 5/4 inch external floppy drive, and this is the typical 37D sub plug, which is used to connect to external port, especially on the old 5150 and 5160 and more computers, of course IBM. And this is very interesting pieces of equipment, since it's a standalone with its own power supply. Unfortunately, I was not able to find any information about this unit, and if anybody of you have some schematics or service information, I really appreciate if you could send me a copy somehow. So, but this time I'm going to open it and see the condition inside, and if we'll be able to work again. So let's go and remove the cover. In order to remove the top cover, I had to flip over, and in the bottom side there are 8 screws which hold it in place, and there is also this stickers which said us that is designed for both 100 and 240 volts, so it should be fine for me, and both frequencies, so should be an electronic way to regulate the motor speed. So let's see if we can switch the internal voltage selector, or if it is doing by itself. So let's try to remove the cover. I just move a bit back, so let's see if I'm able to. Yes, okay, so let's flip it over again, and not easy to come out. We don't know how many years is that nobody is in, if somebody has been in. So let me try to do it off camera. Okay, if you are going to do the same job on this unit, take care of the tabs here. They are really fragile. I've been able to open without any damage, but they looks like really fragile. So these 4 small tabs here and the relevant seats over there. So let me put this aside. It seems that also the front panel should pop out easily, but it seems a bit dangerous. So of course there is a lot of dusty, and as you may imagine, this is a very old equipment. I didn't check actually yet the manufacturing date. Maybe there is something here. I don't know if those numbers can relate to the manufacturing years, or maybe this one in 1986. Perhaps this is the right manufacturing date. So this is the model actually, so this should be the manufacturing date. Okay, as you can see, we have two main sections, the floppy drive itself and the power supply. So I'm going to remove the shields and see the condition inside. Removing the central screen, well, it appears immediately clear that we have the Molex connector right here and the data cable that is going exactly to this external connector. So I'm going to remove the power supply first and see how it looks. Okay, so I should be able to remove the power supply. There is last screw remaining. Okay, so let's go right to the floppy drive and remove also the drive itself. All the screws are removed. Okay, so also the drive is out, and yes, this is very fragile pieces. There are very small tabs over there. So I have removed all the metal parts, since all these plastic parts require very deep cleaning. Put this aside and put aside also the floppy drive and start with, put aside also the other things, make some more room, and start to check this power supply, how is inside. I have brushed a bit the metal case in order to give, to let it be at least touchable, and I immediately see something really odd. The metal sheets are sealed together with rivets, so it's riveted on both sides. There are two rivets plus four banded tabs. So it's clear that must do some mechanical action in order to open it. So let me try to do it with some pliers. So with these flathead pliers, I've been able to bend on the other side those tabs. So this is the easiest part. So let's see if I can find a tool that can help me to close the rivet and let it fall on the table. And to remove this rivet, I have used on the other side this terminal trimmers. I don't really like this method, since I can damage this kind of tool that need to be sharp to cut the terminals easily. However, since there is a very small amount of metal that coming out from the lower side, this is the only tool that I have available, and luckily it doesn't damage it. So I will punch the rivet out and crack it open. Okay, so to punch the rivet out, I have used this punch. I have this series of punches that are really helpful. With just a plastic hammer, I've been able to pull it out. I went on the ground on pieces of wood, since I don't want to give a nasty shock to the unit and all the other things on the table. So I'm going to save this, but I will not fit back again, since I don't like this method. For any future troubleshooting, I would need to punch out again, so I will install screws in place. So let's try to open it. Okay, so we have several wires that prevent the shield to come out. So let me remove them and I'll back. I have removed the strength relief on both wires, so now I should be able, ta-da, to open it. And well, it's quite dirty. Let me put aside this shield. And well, but it doesn't look really bad. So let me give a deeper look. And yeah, maybe now you can see a bit better. Okay, I will move the camera so you can see better. Well, actually it appeared to be a standard switch mode power supply. And here we have, of course, the input filter and the bridge rectifier and the main capacitor, and then probably this is the switch transistor, and as well as these optocouplers for feedback from the secondary section of the power supply. This should be voltage regulation or the overcurrent protection, not really sure. But all in all, seems that nothing really strange, except, well, I'm not sure that you can see. Let me try to zoom in. There is this part that is bulging on this side, but it seems natural. I don't think is something that is that relate with the malfunction or damage. So I'll remove the board from this metal shield, and so I will have also the bottom side exposed and see how it looks down below. So I've removed the board from the shield, and underneath nothing really strange. Is a pair and some oh no, we got a problem here. Oh, look at that. Here there is a very cold joint and with a very weak solder joint. So perhaps it doesn't gave any problem in the past. However, the unit has been sold as non-functional, so it does not power on. Not really sure why. So perhaps the fuse is blown. So let me grab the ohmmeter, test meter, and see if we found a good or blown out. Well, actually the fuse is good. Oh, sorry, you are not seeing it. Let me move back a bit and put in a better position. Yeah, fuse is good. So I wonder how this should be modified in order to run at 240 or 100 volts. So let me study a bit, and then I will figure out how it was designed. I was trying to give a very quick brush to the board, and I have seen that there is a very strange liquid, greasy contamination. I don't know if you can see, and it's quite in all of the board, and it's quite greasy. So I don't know if in the past something drop in some liquid, maybe from the top of the case. So this board need to receive a good clean and also a very degreasing treatment, since it's very bad. So let me clean it up and see the result. After 20 minutes of cleaning with a degreaser product, the bird still not is sufficiently cleaned, but expose something that it is expected. I'm not sure that you can see in camera, perhaps yes. So as you can see, underneath this capacitor here, there is a very huge amount of oxidation signs. So it's a leaking acid coming from the capacitor, and also from this one, and perhaps also from that one. So it's clear that this bird requires fully recap. Not sure if also the main capacitor need the same thing, but look at the Q-tips condition. So this capacitor has spread around the bird this oxidation, as usually do those kinds of capacitors. So time to remove and see if I can replace them, if I have a replacement in my hand, and I'll back. This is the first capacitor removed. Unfortunately, you cannot feel the very nasty smell that produce when this residue is heated up. So I think that this bird in the end will need a very deep cleaning, and when I say cleaning, I mean washing, exactly under water, because this is a very nasty dusty. So this can produce time by time a worst oxidation. So of course the treatment with vinegar is very nice, but in this case I think it's much better to wash it underwater and heat it up with the heat gun. So let me go ahead with the removal and see what I can find. I've done very quick handmade drawing of the capacitor places as reference, so to doesn't make any mistake, since I don't have any schematic. And on the board there are leakage signs everywhere except in the main input capacitor. So I believe that all of them are leaky, but I will test later. So it's time to clean the board. The board is washed, recapped, with the exception of the main input capacitor, which I've tested and it looks really healthy, so no problem. The only difference between the original one is that in place of two 1000 microfarad capacitor that work in parallel, I have substitute with one of 2200 microfarad, so it's slightly different. Just because I don't have in my hand, I have only one. So I will place an order with containing the capacitor that I didn't have the exact match. That you can see it's a little bit bigger because they are higher voltage, same capacitance but higher voltage. So it's time to plug to mains with variac and see if it is able to produce any output. So let's go right to the first test. According to what is stated on the board exactly here, we should have two output voltages, and this is of course what it is expected, since we should have plus 12 and plus 5 in order to feed the floppy drives as usually. So both are rated at 1.1 amp. Right now both of them are without any load, so we have only the test meters on the outputs. I will plug in and start to rise up the voltage with the variac. So let me plug in. Okay. So I'm not quite sure that the input switch over there is in the on position. Perhaps should be like that. Let's see if I can figure out. Yes, that should be the on position. So I'm going to increase the input voltage, the main. So we are now to 20, 50. Okay, look at that. We are at 80 volts and the power supply is already running. Both voltages are a little bit lower, but seems that we have a running power supply. So let me increase a bit more. Okay, we still continue to have a lower voltage. Perhaps we need to reach a higher voltage, but actually it is stated that should run from 100 to 240, so should be ready to the right voltage output. Or maybe we need to tune a bit the output regulation, the trimmer right here, since let me move the camera a bit, since I have washed the bird and maybe something is changed. So let me try to regulate. Yes, and indeed it regulates, and the plus 5 is almost at the right point. Plus 12 still is a bit lower, but should not be a problem. I think it's completely fine. So what I'm going to do is to increase. So I'm now at 120, 150, 180. So it's quite good, the regulation. Actually it doesn't move it at all. And 190, 200, 220. It's fine. So I think at this point I can try to connect some load on the output and see if we can have some strong result as we hope. So let me make a different setup. Okay, this is an 8.2 ohms connected right to the 5 volt output, so should drain about 600 milliamps. So let's try to start it again with a variac again. So okay, and indeed we have a drop, and this is something that is expected, of course. Okay, I'm going to 150 volts. So the drop on the 5-volt rail should allow me to adjust the output voltage, and perhaps we reach on both sides. Yeah, look at that. So now we have the opposite. We have plus 12 almost correct and a bit lower on the plus 5. So I believe that this power supply is designed in a such way that when it's connected right to the floppy drive, should have the exact load. So far so good. And now I want to remove from the variac and connect directly to the line and see the behavior with a full jump to the line. Let's see. We are now directly on the line, and 3, 2, 1. Yes, it's running. Plus 12 perfectly, plus 5 a bit lower, but it seems that it worked fine. So that's it for this video. Next one will take care of the floppy drive. So thanks for watching and see you soon.